Hi, good evening. My name is Carol, and today I'll be presenting the use of analytical technique, high performance liquid chromatography to detect glyphosate through both a scientific and ethical lens. This presentation is going to be based off an article published in 2024 that explains how HPLC can be used to detect glyphosate. So we're going to move on to what glyphosate is. So glyphosate is an organic acid and its composition is an amino, carboxylic, and a phosphoric group. And it's very water-soluble compound with a deuterionic nature due to having four ionizable sites. Because of the glyphosate's makeup and nature, it can be used to help prevent soil erosion, but it's primarily used to control weeds in our crops, and it's used throughout the United States. So although it is used in the United States, it's banned in some other countries, and then we'll get a little bit into why later on to this presentation. So like this compound is primarily used to control weeds, and this is because glyphosate is able to inhibit an enzyme in plants, and shortly it's known as EPSPS. And what this enzyme is responsible for is for the development and growth of plants. So when the glyphosate is sprayed on our plants or crops, it inhibits the growth of weeds. And the reason the herbicide doesn't affect our crops we want to harvest is because the crops we do want to harvest are genetically modified to resist certain herbicides, and glyphosate is one of those. They are genetically modified to resist. So in this way, our crops are not affected, only the weeds are. But once the herbicide has been sprayed, it's done its job. The question is then, what fate is the glyphosate is in the environment? So generally, glyphosate will be degraded from microbial activity in the environment, so that's what its fate will be. And this typically happens in the soil, as glyphosate can be degraded by UV light, although this is very rare. So it typically happens in the soil. So once the degradation in the soil begins, there are two pathways that the glyphosate can degrade into. And depending on the environment, the temperature, but more importantly, the type of bacteria present, glyphosate will degrade into either AMPA or glycoxylic acid or sarcosine. Um, and if AMPA is formed, there will be a carbon to nitrogen cleave, while there will be a cleaving at the carbon phosphorus bond and sarcosine. So this is how the pathways are created, and the pathway that glyphosate usually degrades into is AMPA. So once the glyphosate has broken down into either one of those two pathways, it will then further degrade into more simpler molecules like carbon dioxide. There has been some concerns about glyphosate and specifically AMPA leaching into water and staying in the soil, especially because both AMPA and glyphosate are very water soluble. And because of this, it's very difficult to remove them from the water once they've reached it. And if it stays long enough, it can even lead to the contamination of drinking water, as it can reach underground water drinking sources if the glyphosate or AMPA don't degrade fast enough. And dangerous, as it can affect health of both humans and aquatic ecosystems, but because it has reached that drinking water, there is a safety limit we have in place to make sure that the populace is safe from both compounds, because like I stated before, it has been able to reach drinking water, and even now we probably are consuming some of that glyphosate in its metabolite. I'm now going to move on to the toxicological effects of glyphosate with a Christian worldview. So certain studies have linked glyphosate and AMPA to carcinogenity, endocrine system issues, and developmental issues in humans. because of how well that compound can bind to certain sites in the human body. And the compounds have also been linked to negatively affecting both plants and animals in the area that they're in and causing similar issues to animals to that in humans. So, like the endocrine system issues. And it specifically affects plants as those that are not being harvested aren't genetically modified to resist AMPA or glyphosate. So that's something we have to take into account when we are doing agriculture. Is not everything that's growing in that area is going to have that resistance. And from a worldview standpoint, we can look at Genesis 2:15, where the Bible states, "The Lord God took the man and put him in the Garden of Eden to work and take care of it." And basically, what that's saying is to take care of each other and all creations on earth. So it's our duty to kind of make sure that we don't poison the earth for our benefit, and just make sure that we maintain those safety levels, at least when using certain chemicals such as the herbicides, and just making sure we try to prevent them from leaching into the environment and affecting other plants and animals. So now we're look at the article published in 2024 that discusses using HPLC to detect glyphosate in its metabolites. So the main concern in the article is that it's actually quite difficult to detect glyphosate and its metabolites, especially in complex matrices such as food and water. And in the article, they're looking for different cereals made with different grain-based foods and seeing how well they can detect glyphosate and AMPA in these foods. And like glyphosate is hard to detect, especially because the compound has a low volatility, high polarity, and they just don't have enough chromophores to absorb UV light. So common detection methods like GCMS, they're not going to work as well. And then the article addresses a solution outside of the common method used to detect glyphosate and AMPA. The go-to method is usually LCMS MS, but in the article, they're going to be using HPLC paired with fluorescence detection in order to add additional detection methods for safety regulations. And the short name for that detection method is HPLC FLD. So in the future, when you're hearing that, that's the detection method that they're going to be using, is that fluorescence detection method. So when using the go-to method, the LCMS-MS, there is no derivatization that's needed, but with the new detection method, HPLC FLD, derivatization is needed because we need that fluorescence in order to detect the analyte. And if you remember before, glyphosate, it's missing that fluorescence, those chromophores. So they're going to have to add that extra technique so that the analyte can fluoresce. So now we're going to move on to how the cereal samples are prepped for this test. So first, the samples are obviously ground up into powders so that they can be used easier. And then they're going to be homogenized and extracted using an acid or an aqueous solvent accordingly, depending on the type of grain. So solid phase extraction was then used to remove impurities and then used to reduce interference during the detection for unwanted substances in the matrix. So the samples were then centrifuged to remove further impurities and help with that separation. Separation was completed. They then moved on to the derivatization, again, because glyphosate and AMPA are lacking those absorbance capabilities. So a derivatization agent called FMOCCL was used because it's able to react with those amine groups and both compounds in both glyphosate and AMPA. So when FMOCCL binds, it'll form a product that is able to fluoresce and then be detected with the HPLC paired with that FLD. And for this analytical technique was at least 1 milligram per kilogram with a limitation of 0.5 milligrams per kilogram. So once the derivatization was complete, their experiment was validating using other research articles with very similar tests conducted for each whole grain tested. So the detection limits, linearity, recovery, and accuracy were all validated. And it was found that the range of recovery for the HPLC FLD method was about 80 to 110%, with the method meeting or exceeding the European Union's acceptable daily intake, ADI for short, regulatory limits of the glyphosate and AMPA found in grain-based foods. So the findings from using the new method, the HPLC FLD, showed that the glyphosate and AMPA were more concentrated in wholemeal due to the outer layer of the grain preserving more of the compound. So cereals that used the wheat had the highest concentration of glyphosate, with the concentration ranging from 6.1 to 11.1 kilograms per milligrams. The GM soybeans were found to have the highest concentration of AMPA, with the concentration being 0.9 kilograms per milligrams. And just for reference, the ADI acceptable limits for glyphosate consumption in food and water was 1.75 milligrams per kilograms, while for AMPA, it's 0.5 milligrams per kilogram. So these two concentration values were a little bit concerning because these values were obtained from cereal products that they had pulled off shelves. So it's a little bit concerning. And you'll see a full list of the concentrations found in different grains from the different cereals that were tested. And in conclusion, I would say glyphosate plays a huge role in modern farming, but it's also a chemical we kind of need to handle very carefully. And advances in chromatography, such as the new HPLC FLD method, would help us to detect this analyte a lot more precisely. But we also obviously need an ethical framework to decide how to use these tools properly. And here you'll see the main sources I use. The most important citation will be that 2024 article, the chromatographic methods for the determination of glyphosate in cereals is what was used to describe the HPLC FLD method. Thank you.